Okay, so we would like to make number 43 and 14.5 is we would like to make a tangent plane to f of x and y is 9 over the quantity x plus 4y at the point x is 1 and y is 2. Okay, so the first thing you need to conjure out of your brain is what? Yeah, some kind of equation for a tangent plane. I do not care where you get that. And so if what you want to do is try to make some mega function of x, y, and z and set it equal to a constant k, and then calculate the gradient and dot with a displacement vector, you could totally do that. Given that this one's already written as a function of x and y and that the partials aren't going to be so bad, I'll probably just do this the old school way. So I'm going to kind of think to myself, L of x and y, right, is what's your dumbest guess? Yeah, whatever the height is at the over the point, what, 1, 2, right? So I'm just going to do f of 1, 2. That's my dumbest guess. Which is, what did you say? 1. 1? Cool. Okay, what else could I do to refine my dumbest guess? Yeah, I could add the partials in each direction, right? So I could do like x slope times something plus y slope times something. What are your something? Yeah, so those would be your x run, right? X minus 1, and your y run, which would be y minus 2. Cool. Okay, so then I just need to figure out what the x slope and the y slope are. So what are the x slope and the y slope? So x slope should be an x derivative, right? Okay, so I should do fx, and then where should I be evaluating fx? 1, 2. Why shouldn't I just cram fx in there? Yeah, it wouldn't be a plane. It would be a decent approximation, like right at that point, but it wouldn't be a plane. You guys see that? It would be a horrible approximation elsewhere, just so we're clear. Okay, so how do I get fx? This thing? Think about that thing as 9 times x plus 4y to the minus 1. Okay, so fx as a function of x and y is what?
Negative 9x to the negative second.
Negative 9, how about x plus 4y to the negative second? Right, this is leave the constant, drop the power, the stuff to the one lower power, times the derivative of the stuff inside, right? Which is, in this case, 1. Okay, great. So then evaluate this at 1, 2, and you get whatever you get. Negative 9 times, what was that? 9 to the negative 2? I think you get negative 9. Okay, so I put that over here, negative 1 over 9. Maybe with parentheses, so I don't screw this up. Okay, and then you need fy, right? Of x and y. So you get like stuff, right? So I get negative 9 x plus 4y to the negative 2, and then so the derivative of the inside is different y this time.
Because
because I'm differentiating with respect to the other variable, right? So I get a 4. And so I get, when I evaluate fy at 1, comma 2, I get negative 36 over
That'd be like 4 over 9.
Yeah, it'd be negative 4 over 9.
Oh, are you asking what's on the
Oh,
bottom?
yeah, thank you. It's negative 4 over 9. How about that? We already know one of the 9s is going to cancel. Boom, boom. Check. Cool. Where are you hung up?
I was just curious how you did the tangent plan and then actually plug in those values because we've only ever dealt with 3 dimensions and it was kind of reconnected given 2 dimensions instead of this one. So I'm just curious how that would pan out.
Cool. Does this make sense?
Yeah.
And ultimately, you should call this thing something, right? So I'm going to call it L of x and y, I guess. What would another good name for this thing be?
Z.
No, that would be a horrible name. Yeah, that would be fun. Alternatively, maybe T of x and y for tangent plane.
So that's your answer there?
P of x and y for plane. Yeah, this is as far as I'm going to go.
The one they gave was like x plus 4y plus x equals 18. I was kind of confused how they made it that. I guess it's a lot of multiplication.
X plus 4y equal 9z maybe? Yeah, so they just did algebra to this.
Okay.
They called L of x and y z, and then they said, okay, we'll multiply through by 9 to clear the bottoms. So we'll get 9z is 9 minus x minus 1 minus 4 times y minus 2. And then they did a little distributing, and then they shoved the x's and y's and z's to one side and left the other side. Cool. I would personally rather leave it like this, because I can read the tangent plane's normal vector right out of this. You guys see that? Tangent plane's normal vector is minus that, comma 1.
So when this comes up on the test, you want us to leave it in that form rather than,
Yeah, you can leave it in whatever form you've come to first.
okay.
I would
Cool.
really rather not count off for stupid arithmetic errors.
Awesome.
So the less arithmetic you can do, the better, right?
Right on.
Because I would like to go through my life thinking that you can do arithmetic. It's much better for me if I can think that, even if it's not quite true.
Yeah.
Cool?